Hello and welcome to another one of my videos on the topic of management science, where we utilize Microsoft Excel to model and then set up simple everyday business problems. Now, if you're watching this video on YouTube, please refer to the description below the video, and there you will find a link to the corresponding blog post for this problem. At the blog post, you will see this problem written out in long form so you can read it at your own pace. And you will also find a download link for this very file. So you can download this spreadsheet and follow right along with me step by step from beginning to end. Now let's go ahead and talk about our problem. And oh boy, is it a problem. Our entire office is in a panic. We are in the beginning stages of developing a revolutionary product. The market for this product is wide open. The margin on this product is great. So for many reasons, we are very excited about this product. Now we anticipate it's going to take 20 months to run through our product development process. However, we have just learned that one of our competitors is planning on bringing a product to market that is very similar much sooner. So we are tasked with figuring out a way to push our product development schedule up within a constraint of $30 million. So we have to figure out a way to move our product faster along its development path without spending more than $30 million. That's going to be tough to do, but we can do it. Now at JIT, all of our products follow a 4-phase process. In phase 1, we have research. In phase 2, we have development. Phase 3 is the design of the manufacturing system for the product. In stage 4, we initiate production and distribution of our product out to retail establishments and so forth. Now, each of those 4 levels can occur at one of 3 speeds: normal, priority, or crash. And the normal speed is what it says it is. It's sort of the normal speed we develop products along our pipeline. Priority is if we have to kick a certain phase into a higher gear and we need to, for whatever reason, complete that phase sooner. And crash, of course, is the absolute maximum speed we can complete any given phase of a project. Now, as you can imagine, as the time frame decreases, the cost increases. So moving product phases into crash carries a substantial financial cost. So it's going to be our job to balance the speed of our new product development with the cost constraint of $30 million. So we are going to go ahead and model that in Excel, use the Excel solver add-in, and then find our answer. However, before we do that, like in other problems I have done, we're going to go into a drawing program and actually sketch out what this problem looks like on paper per se. Now once we do that, you will see how everything is connected, how our product is going to flow, and what it looks like, of course. And then we'll come back into Excel, enter our data, and then solve our problem. So here is the basic diagram of our JIT product development problem. Now, like other problems I've done, we're going to start with a system of nodes. And there are a few things about this system of nodes that I need to point out before we actually go ahead and draw in our paths and things like that. The first thing I want to point out is that, yes, we are starting with a now node, which is the green circle on the left-hand side. But over on the right-hand side, our red circle with the T in it is actually what we call a dummy node. And we have to insert a dummy node there to close off all of our paths. And if you think about it, the reason we have to do that is because step 4 is the final step in any path we take. However, in our network, we could have one of 4 different final steps. We could have 4.9, 4.6, 4.3, and 4.0. So in order to have one concluding node, we make a dummy node at the end with an arc length of 0. Now, that will make more sense once we go ahead and draw everything in, but I just want to point out this one is a little different because we could have one of 4 multiple endings, but we still have to have one destination in order to make this type of problem work. Now, speaking of the nodes themselves, of course, the green is where we're going to begin, the red T is where we're going to end, and then all the yellow nodes in the middle are pass-through nodes, or in supply problems we call them transshipment nodes. And that just means we're going to pass through but not stop at any one of them. And that should make sense because our project develops along 4 steps. So 1, 2, 3, and 4. Now, what do the numbers in there actually mean? Have you figured it out yet? Well, the 0 in the first node stands for now. The 1 in that first column, that is actually step 1 of our project, which of course is research. Then we have step 2, step 3, and then step 4. Now the second number in each node is the amount of money we have left out of our $30 million budget. So depending on the path we choose, or the path that is found for us by Excel, it will actually deduct the amount of money we are using as we go. So the first number is whatever stage or step of development we are in, and the second number in each node is how much money we have left to continue. Now remember, we have 3 speeds or 3 levels of product development. We have normal, priority, and then crash, which is of course the fastest but also the most expensive. So we have to incorporate those 3 levels into our diagram. Now, the one good thing is we're only going to have a normal level from now to the first stage. Since we are already in the research stage, we have to account for actually being in the normal level of development. But after the first stage, after the research stage, we're only going to have 2 levels, priority and crash. We're not even going to consider the normal level anymore because we have to get this project done and done quickly within budget. So when I draw the arcs here in a second, I'm actually going to use different colors to denote which level that arc represents. Is it normal, priority, or crash? So I'm going to go ahead and pause the video now, draw in the arcs, and then we'll come back and talk about what we have. So here is our diagram with our arcs drawn in. Now I've gone ahead and used different colors, and you can see the legend there on the top left, to represent the different levels of our product development. So the gray color, there's only one arc with the gray color, and that's from now to the research because we're already in the research stage. So there's only one normal arc in the diagram. Now the light green color is priority, so all those arcs in light green are occurring at the priority level, which is the mid-level, and then the orange arcs are occurring at the crash level, of course, which is the fastest and most expensive. So as we proceed through each stage, once we get to the research stage, we're going to have 2 choices as we proceed. We can either go priority or we can go crash, depending on how our finances are at that time and whether or not that path minimizes the time to development. Because remember, our entire goal here is to minimize the total time of development for our product, because we're trying to push out our product before our competition, but we have to do it within our $30 million budget. Now the way the diagram is built, the cost structure is already built into our nodes. So you see that we start at 30, we go down from 27 to 24 to 21 at the research stage, and that just depends on which path we take, because obviously the crash stage is going to use up more money. That's why it says 21. Then does the priority or the normal stage. The next part of our diagram we have to enter is the amount of time each arc takes. Now remember, that will also depend on whether or not we are operating at priority or crash. The colored arcs represent what level we're operating in, and then I'm going to go ahead and pause the video and actually type in the length in months for each arc. Alright, so here is our complete diagram. Now I've gone ahead and listed each node pair on the left hand side, from and to, and that list incorporates every arc in our diagram we currently have. Now remember, each arc is color coded to denote what level we're working on, normal, priority, or crash. Then I've gone ahead and drawn in the months of completion time for each arc. So for example, if we were to go all along the top, we would go from now to the research stage in 5 months, and then we would go from the research to the second stage in 3 months at priority level. Then we go priority level to stage 3 in 5 months, and then we would go priority level to stage 4 in 2 months. So the numbers on the arcs are actually our time. The 0 length arcs leading from stage 4 to our termination point, that just helps us resolve all of our paths into one point. And because the arcs are 0 length, they don't actually affect our problem. That's why it's called a dummy node. We use dummy variables in statistics all the time. So this is just a dummy node that doesn't have any length, but still helps us resolve all of our points. So let's go ahead and go back into Excel, enter our data, open up the solver, and solve our problem. So here we are back in Excel. As you could see from our diagram, this is a pretty complex problem with many options in it. Now before we actually go in and enter our information and use the solver, I just want to talk a bit about how the spreadsheet is set up and what each section will do for us. Now over on the right hand side you see 3 columns: nodes, net flow, and supply demand. The node column is simply a list of all of our nodes, just like we drew in our diagram, and as you can see over there on the left hand side. The supply demand column is simply a constraint we place in Excel that says, hey, this is where we start, these are all the nodes we pass through, and this is the node where we stop. So the 030 node has a 1 in it because that's where we start. The nodes below that have zeros in them because they are pass-through nodes. And in our case, they just represent phases of our project. So we're going to pass through phase 1, phase 2, 3, and 4. And at the very bottom, next to T, is -1. And that just means that's where our process is going to end. So the 1, zeros, and -1 in supply demand are simply start, pass through, and stop. Now the net flow column, we're actually going to put a formula in there that sets up a constraint between our supply demand we typed in and what Excel finds for us. So the purple column and the blue column have to be the same once we solve our problem. Now on the left hand side, on the long columns, from and to are simply the node pairs for each arc we drew in our diagram. So that's just a long list of arc pairs. On the right hand side of that section, in the salmon color cell, is time. And that's just simply time in months to complete that arc, just like we wrote on our diagram. Now the blue cell down the middle is on route, or en route. You'll hear me use both of them. And that is actually what Excel is going to find for us. It's either going to put a 0 or a 1 in each corresponding cell. If it puts a 0 in that cell, that is not a route we're going to take. That is not an arc we're going to take. If it puts a 1 in that cell, that is an arc we're going to take. Now down below, in the pink cell, that's our total time. And again, we are trying to minimize our total time in this problem. So whatever figure ends up in total time, that's going to be the absolute minimum time we can complete this product's development within our constraint of $30 million. Now since we have so much already built into the spreadsheet, all we really have to do is enter 2 formulas and then open up and use the solver, and we're going to have our answer in just a couple of minutes. So I'm going to go ahead and enter the formulas, and then we'll open the solver after that. So the first formula we're going to enter is in the top of the net flow column. Now I'm not going to explain the detail of what each formula does. I've done that in previous videos, so if you'd like, go back and watch those. I'm just going to go ahead and type in the formula and then proceed. So our formula looks like this: equals sum if, so it's a conditional summation formula, from H4, comma, on route. Got my 4. Okay, so sum if, parentheses, from, comma, H4, comma, on route, minus sum if to H4 on route. Okay, so sum if from H4 on route minus sum if to H4 on route. We'll go ahead and hit enter. And again, that's going to be 0 right now because there are no figures in the on route column, so it has nothing to go off of yet. So we're just going to drag down that entire column. It's one of the great features about Excel. We can just drag down and it changes the H cell in each one. Okay, so only one more formula to go, and that's in the total time field at the very bottom of our spreadsheet. And that is equals sum product on route, comma, time. Close parentheses, enter. That's it. That is it for our formulas. So the net flow column is going to make sure that our supply and demand constraint is met, which is the blue column of cells on the right. And then the total time cell is going to take the ones and zeros in the on route column, multiply it by the time column, and then add those together. So if we have a 1 in the top cell of on route, that will be 1 times 5 plus the next one in on route times the time plus the next one in on route times the time, etc. So the sum product formula just multiplies two corresponding arrays of cells. Okay, so let's go ahead and open up our solver and solve for our answer. So we'll go to Data, Solver, and in the Set Objective field, this is always what we're trying to minimize or maximize. So our objective in this problem is total time. So total time, which is the pink cell down there at the bottom. And we want to minimize that, so we're going to click the MIN radio button. Now we want Excel to change or manipulate and actually sort of solve for the on route cells. That's the blue column down the middle. So by changing variable cells on route. Now we do have one constraint in this problem, so I'll go ahead and click Add. And it's just how it appears in our spreadsheet. So net flow equals supply demand. So net flow equals supply demand. Go ahead and click OK. Now really that is it. Just check to make sure that the Make Unconstrained Variables Non-Negative box is checked, which it is by default. Select Solving Method. We need that to be Simplex LP for Simplex Linear Programming. Now, if we spelled everything correctly in our solver, click OK or click Solve, and we should have our answer. All right, and it says Solver found a solution. All constraints have been satisfied. Do we want to keep our solution? Yes, we do. Let's go ahead and click OK. Let's go ahead and look at what we have here. Now I'm going to start on the right-hand side for net flow and supply demand. If you notice, our purple column for net flow is a mirror image of our supply demand column on the right-hand side in the blue, so that is good to go. That means that we did in fact start at 0:30, went through all of our nodes, and ended at T. So we're good there. Now, of course, the most interesting column is over on the left-hand side. Now, in the on route column, we have a series of ones and zeros, like I said before. But what exactly does that mean? All that means is that wherever we have a 1 in the on route column, that is an arc we are going to take. So our first path through our diagram will be from 0:30 to 1:21. Now I'll bring the diagram back up at the end, but if you remember, that is leading us from now through our crash route to the research phase. Now if we go down, we're going to be going from 1:21 to 2:15. Go down further, we'll be going from 2:15 to 3:3, and then we'll be going from 3:3 to 4:0, and from 4:0 to T. Now that last one really doesn't count because it's a length of 0, but it takes us to a common endpoint. One thing I want to point out as I highlight these again is that notice the last number in each pair is our budget. The first number is what phase we're in or going to. So we're going from phase 0, which is now, to phase 1. Our budget is going from 30 million, 21 million. We'll go on to the next one. We're going from phase 1 to phase 2, and our budget is going from 21 million to 15 million. Go down further. We're going from phase 2 to phase 3, and our budget is going from 15 million to 3 million. And finally, we go down to the last actual meaningful step. We're going from phase 3 to phase 4, and our budget is going from 3 million to 0. So we use every penny of our budget to speed up this development process. Now, by how much did we cut the time? If you look down in total time, it is now 10 months. We have reduced our product development time from 20 months in half to 10 months. And because we have cut our time in half to 10 months, you know what? We're going to beat our competitor to market and take advantage of being the only player in that market for a while. And really, that is it for this problem. Thank you for watching. I look forward to seeing you next time.